Okay, now we are going to look at graphing these functions and the parent function. My first one here, g of x, is x minus 4. As for the parent function, the linear function was f of x equals x, and this time we have g of x equals x minus 4. This, subtracting 4, means it got shifted down 4. The parent function itself had a slope of 1 and it hit the y-axis at 0. So this is my parent function. So I'll call f of x the parent function. The g of x that they gave us is shifted down 4. So each of those points that I had is going to go down 1, 2, 3, 4. Okay, so there's my point. Again, this one goes down 1, 2, 3, 4. Here's our straight line that was shifted down 4, so this is the g of x. So we had to graph both of them and then describe the transformations. In this case, it was down 4, so I actually already described that. It was down 4. And then find the domain and range. The domain has to do with all the x's, both of which have arrows on the end, so the domain is all real numbers for both of these. And the range, again, those arrows mean it's going to go down forever and up forever, so it still is going to have a range of all real numbers. Okay, so that had to do with our linear function. Let's look at number 4 here, negative x squared. That has to do with our quadratic parent function. Based off of that, let's draw the parent function first. Parent function hit at 0, 0, 1, 1, it hit 2, 4, negative 1, 1, negative 2, 4. Okay, so that was our f of x, our parent function. This p of x here, it has a negative in front, which that negative itself is going to be a vertical reflection, meaning that up and down is vertical. It will now be facing down. It's going to go down to a negative 4 and a negative 1. So this one they called p of x. Okay, so we did again say what the transformation is. It's a vertical reflection. And as for the domain and range, the domain of the p of x, the domain of this one, is all real numbers because it is going to go left and right forever. Slowly, it'll go to the left and slowly it'll go to the right, but it will go to the left and right forever. The range, the y values. Now again, I'm looking at the p of x function, and this actually has a highest y value. 0, 0 is like its highest point, and then it hits everything below 0. So for my range from negative infinity, again, the arrow is pointing down. It's going to go all the way down to negative infinity, up to 0, and it actually hit the 0, so I put the brackets there. Another way to say the same thing is to say that it's all the y values less than or equal to 0. It actually hit the 0 and everything below it. Next up is the h of x function, 1/2 the absolute value of x. So the parent function hit at 0, 0, at 1, 1, 2, 2, 3, 3, and then negative 1, 1, negative 2, 2, negative 3, 3. It was this like sharp V with the little arrows on the end, like it continues forever. Okay, so there's the parent function. I will call f of x. And the h of x here, it's got this 1/2. Multiplying by half, we've got half as much, it makes it smaller. So this is actually going to be a vertical shrink by 1/2. So let's see what that means. Instead of hitting this point right here at 2, it actually is going to take a half of that and it hits at 1. It's going to take a half of each of these y values. Even if it's like the 3, half of that is 1.5. It'll be the same thing on the other side. Okay, so what I have in black here is the h of x that they gave us. Okay, so for this h of x function, the domain, it still has arrows on the end. The black one, the h of x, it still has arrows on the end. It will go to the left and right forever, so it is all real numbers. But the range is not all real numbers. The range does have a lowest y value. That lowest y value is 0, and it hits everything above 0. It's got those arrows showing you it'll go on forever. You're going to go from 0 to infinity. Again, the square bracket on 0, meaning it actually did hit that point. So you can also say y is greater than or equal to 0. It hit the 0 and everything above it. All right, now these last couple of problems, are having us do more than one of the transformations at the same time. In this case, the parent function is the absolute value function again. So let's draw the absolute value of x. That would be right here, hitting 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. There's our parent function. And now we need to deal with our transformations. This negative right here, this is a vertical reflection. It's like what we had up here on our parabola. We had a vertical reflection because there was a negative multiplied out in front of our function. As for all of the addition and subtraction, that has to do with shifting it one way or another. This x plus 5, my x's go left and right, so x plus 5 will actually shift everything to the left by 5. And then the minus 3 is going to be another shift, but it will shift everything down by 3. Okay, so let's take some key points here. I'm going to take like my 0, 0. I'm going to go left by 5, 1, 2, 3, 4, 5, and down 1, 2, 3. Okay, so then the point 1, 1 here, it's going to go left by 5, 1, 2, 3, 4, 5, and down by 3, 1, 2, 3. Okay, so it gets here. It's going to be very similar, except for I haven't dealt with the reflection yet. The vertical reflection means that it actually is going to be facing down now. So this is going to be, here's our reflections kind of off the graph here. Okay, so this is our m of x. The f of x was the parent function. Now we have this m of x that had a vertical reflection and it was all shifted left by 5 and down by 3. The domain of this m of x function, it still has arrows on the left and right. It will continue left and right forever. So all real numbers for the domain. The range, y values, it looks like there's this y value and it's everything below that. So from negative infinity, that's the lowest y value, all the way up to, this is a negative 1, 2, 3. So all the way up to negative 3, and it actually hit that negative 3, so I've got the bracket, the square bracket on that. You can also say it is all the y values less than or equal to negative 3. All right, and our very last one here, we've got the parent function x squared. Hits at 0, 0, hits 1, 1, 2, 4. So I've got my parent function here. I'm going to call the parent function f of x. And then the transformations they've got, a lot of times people consider the negative 0.25 as a single transformation, but it's not. I'm actually going to consider the negative itself is a vertical reflection. And then the whole multiplying by 0.25, that is taking a quarter of something. It's making it smaller. So this is what we're going to call a vertical shrink. So again, I'm doing the negative separate from the 0.25. And then the plus 4 here is going to shift everything up 4. That means we've got the vertical reflection, like it should be facing down now. And then the vertical shrink, a quarter of something. I think 4 is probably a good example. We know a quarter of 4 is 1, so it got shrunk all the way down to a quarter of it. Now, a quarter of 0 is still 0. So that's going to stay there. It's just going to be this wider function. And again, like I said, it's a reflection. So this is going to go a negative 1, negative 1. Okay, so I took care of the reflection. I've taken care of the whole shrink. But now it's got to get shifted up 4. So that 0, 0 point is going to go up 1, 2, 3, 4. Okay. This 2, negative 1 will get shifted up 1, 2, 3, 4. All of them are getting shifted up 4. 1, 2, 3, 4. Okay, so now I have some points that I can actually connect for my final graph. It's a much wider parabola facing down, and it got shifted up 4. This is what they called t of x. And that t of x function has a domain of all real numbers. It does go to the left and right forever. And the range has to do with the y values. It does have a highest y value up here at 4, and then it hits everything below that. So I'm going to go from lowest to highest. So I'm going to go from negative infinity up to the highest thing that it hit, which was at 4. And it actually hit that number, so I will put a square bracket. You can also say it's everything less than or equal to the 4. It did actually hit the 4, so make sure you've got that equal to bar. All right, there we go.